All right, welcome back, Algebra 2. This is Chapter 3, Section 1, entitled Solve Linear Systems by Graphing. So nothing we do today should really be, well, will be one thing, but not many of this stuff will be new to you. A system of two linear equations is simply multiple linear equations. A lot of times they'll look like y equals 2x plus 3, and another one y equals x minus 4. That is a system of linear equations. A solution satisfies both equations. Alright, so what this means is a solution satisfies both equations. If we wanted to check negative 7, negative 11, if we were told that this is a solution to the system, you'd have to actually plug it in and see if it works. So you'd have to put negative 11 for y, negative 7 in for x, and you'd end up with an equation like this. Y is negative 11, 2 times negative 7, that's negative 11 equals negative 14 plus 3. Negative 11 equals negative 11. This is a solution to that first one. So it has to satisfy. That's how it satisfies the equation. Okay, remember, consistent. There are solutions. And there may be one solution, or there may be infinitely many. Inconsistent, you say no solution. Independent, you say exactly one. And dependent, you would say many. You'd actually would say infinitely many. So those are the vocabulary words. Now let's talk about how we go about doing this. So the first thing you're going to want to do, solve a system graphically. I want you to add here that, put this in your notes, that graphing may not be exact. All right, if you aren't awesome at graphing, your answer might not be an exact answer. So let's look at these. These equations here, graph the system and estimate the solution, then check the solution algebraically. So you take a look at these. These are in standard form. So right now you're probably going to want to just use the cover-up method, the finding the intercepts. 4x plus 2y. Back from chapter 1 or chapter 2, it says, forget about the y. The x-intercept is 1. Then forget about the x. The y-intercept is 2. So you have, for the first equation, y-intercept of 2. X-intercept of 1. We've got two lines, and you're going to draw the best graph, the straightest line that you most possibly can out of there. That's why this is not exact. Then take a look at the next equation. This one's a little bit too harder. 2x minus 3y equals 10. Well, just like before, get rid of the y. X should be 5. Then get rid of the x. Y equals negative 10/3, which is approximately 3.3 repeating. Negative 3.3 repeating. Right there. So now when we draw the straightest line we possibly can get through those points, you're going to see that right in here, as long as your answer is somewhere near this, you're going to get it correct. All right? Graphing's not exact. I don't expect you to have it be exact. I'm actually going to look at this and say that, well, according to our graph, looks like the solution is right here. So that's 2.5, 1.5. Now, when you check the solution algebraically, you'll see these points don't work. If I'm not mistaken, I'm pretty sure that the answer to these is much closer to -2. But you'd only would know for sure if you checked algebraically. All right, so here's another one. Let's graph this. We should be all on board with graphing. So right here, the y-intercept is -2. The x-intercept is -1/2. And now I draw my perfectly straight line through those points. So here, now we've got these points to graph. So -6x equals 12. That tells me the x-intercept of -2. I know that -3y equals 12. So that means y equals -4. And then when we graph this, I'm going to say the solution is right there. So I'm going to say the solution to this equation should be -1, 2. And we would only know that if we were correct if we checked the answers. So I'm going to do quite a few of the guided practice for you today. Number 1 is 3x plus 2y equals -4. The next equation is x plus 3y equals 1. And now we graph this. You can do it, you put it in this y equals mx plus b. You can graph the intercepts and draw the line. You can find 2 points however you want to draw the line. So, let's see here. Right here, for the first equation, 3x equals -4, so x is -1.3. Then you have 2y equals -4, so y equals -2. So y is -2. The x-intercept is -1.3. There's the equation that is brand new to us. The other equation, right here, again, let's say x equals 1, 3y equals 1, therefore y equals 1/3. So now you've got y is 1/3 right there. You've got the x-intercept of 1. And now, with a different color, we're going to go ahead and try to estimate the solution. I'm going to estimate that the solution is -2, 1. The only way you would know for sure is if you checked. Alright, so that is number 1. Number 2. So 4x minus 5 equals -10. 2x minus 7y equals 4. So we're supposed to use graphing this. So you could put it in mx plus b form, or you could just say that y equals, I'm sorry, negative 5y equals negative 10, so y is 2. So we just graphed y equals 2. Now let's get rid of the y, so 4x equals negative 10, divided by 4, x is about 2.5 negative. So here's kind of how your graph should look. Now the bottom one, 2x equals 4, that means your x-intercept is 2. Negative 7y equals 4, that means y is approximately negative 0.5. And so here's your graph. Your solution should be somewhere inside that circle. All right, so that's solving it graphically. Now, we're going to talk about the different kinds of solutions. Number of solutions of a linear system. There's exactly one if the lines intersect at a point and you would say it's consistent. You would say it's consistent and independent. If you go back to the definitions we did a couple times, you would see that if there's exactly one solution, then it's consistent, independent. Here, lines blank, it means it's consistent and dependent. You could say that the lines are the same. They are dependent. Lines are parallel. Then you would say that this is inconsistent. All right, so we got quite a few slides to do. Let's work on it. Solve the system, then classify the system as a consistent and independent, consistent, dependent, or inconsistent. So let's take a look at this. Let's look at this equation right here. Notice that all of them are even numbers. So I would say rewrite this system as negative 2x plus y equals 4. Divide everything by 2 and you get 2x minus y equals negative 4. And let's take a look. Let's go ahead and if we divide by negative 1, you end up with an equation that looks like this. So what you end up with are the graph of the equations are the same. So each point on the line is a solution, and the system has many solutions, therefore the system is consistent, independent. Consistent, independent. All right, let's look at the graph here. So intercepts. Y-intercept is 4. X-intercept is negative 2. Look at the other way now. The x-intercept is at negative 2. for one of them, and y-intercept for the other one is that. So you end up with 2 points that are exactly the same 2 points. Therefore, the straight line has to be independent, consistent, and independent. So solve with no solution. No solution means they are parallel. So the graph of the equations are 2 parallel lines, therefore the system is inconsistent. So, get rid of the x. 4y equals 8, that means y is 2. Get rid of the y. Your intercept is negative 4. And we draw our line. Then, get rid of this one. The x-intercept is at 2. The y-intercept is at negative 1. And what you should see is that these two lines end up being exactly the same except just shifted up. So you would say no solution. Alright, I promise we'll try to get through this pretty quickly. So we're going to solve these graphically. So this one right here, get rid of the 2y, that means the x-intercept is at negative 2. Get rid of this part, the y-intercept is at 3. The next part, four y equals 8. The y-intercept is 2. Up here, get rid of this. You can graph it from there. So from here, it's that, and then it's then when we're trying to find the x, negative 8/5 is about 1.6. So you know if an equation looks like this, and I would say the solution's pretty much looks like negative 1, 2. Check it to make sure though. Alright, let's look at this one. Let's graph the intercept some more, please. Negative x minus 2y equals negative 5. So negative x equals negative 5, that means x equals 5. Divide by 2, get rid of this part. Divide by negative 2, becomes positive 2.5. There's your equation, your graph. Now, let's find the y-intercept, or the x-intercept. Negative 2x, negative 10, that means the x-intercept is positive 5. Move this part over. Negative 4, negative 10. It's 2.5. Therefore, your equation has infinitely many solutions. All right, let's keep moving here so we can get done with these. Notice here, everything about these is exactly the same except these numbers here are different. All that's going to do is shift the equation. So if the equations are exactly the same, except for the constants are messed up, you will know that these are parallel and that there is no solution. So find the y-intercept Let's look at line 1. Get rid of that. 6x equals, so x is 2, y is if y is 3y, negative 6, 2. Oh, I forgot to do this part. Looks like it's 4. Oops. So y is 4. So 2 and 4. Here y is 2, x is negative 1. You graph it. Uh-oh. You can see we've made a mistake somewhere in here. So I told you that these would be parallel, so let's see what mistake I made. So let's start over. Let's give ourselves some extra room. So for the line number 1, 6x should equal 12, so my x-intercept is 2. Negative 3y equals 12, so my y-intercept should be negative 4. So 2, oh, I'm sorry. So the y-intercept is negative 4. The x-intercept is 2. Now looking at the next equation, 6x equals negative 6, means my x-intercept is negative 1. And then equals 2. And hopefully you can see these are pretty close to parallel, so we're going to go with that. Alright, so I think what happened was I put a positive 4 instead of a negative 4. Take a look at this. The x and y intercepts are all 2. That's pretty nice when that happens. The x-intercept get rid of the y, and 4x equals 1, which is 1/4. And then negative 3y equals 1, which is negative 3 over negative 3, which is negative 1. So now I've got this equation, 1/4 for the x-intercept. And your graph might look something like that. And I would say that 1, 1 is your closest possible solution. All right, guided practice 4 and 6. I think we've been doing a lot of these problems, so let me just do number 6. Negative 2x plus y equals 5. Y equals negative x plus 2. Here it's a little bit different form, but it's as long as we remember all what we learned from chapter 2, we should be fine. So for the first equation, y-intercept is 5. The x-intercept is negative 2.5. Y equals negative x plus 2. So that means y is 2. Oh, let me draw this line in here. So y is 2. And see, I already did that one. So, oh, now the slope is negative 1. So down 1, left 1. So hopefully it looks something like this. And if you look, you might say that that's negative 1, 3. That's the solution you could guess. Alright. Listen, I don't want this to be too long. So go ahead, try the example, the story problems, but really make sure you have the basics down. And I'm sorry this video is so long. I hope it helps though. Have a good time.